Today we're doing problem 296, best meeting point. Given binary grid which is a rectangle and each one marks home of a person and we return minimal total travel distance. Total travel distance is sum of distances between houses of the friends and meeting point. Distance is calculated in Manhattan distance. So in 1D world, what you want to pick is the median point. And that is because, let's say you have guys at 0, 2 and 10 on x-axis. You pick 2 and you might think, won't I pick 3? Well, no, because if you move to 3, then suddenly that guy from 10 has it one shorter, but both guys from 0 and 2 have to go by 1, so the total distance went up by 1. So we want to take median. How to adapt this into 2D? Well, what I would do, basically we need to find median x coordinate and median y coordinate, and that's our meeting point. And we can do that by putting x, taking a list of x and y's, if grid x, y, x up and x, so then we sort them. And then we do what? I don't have N and M, so okay, let's make it a little better. And now finally we return. Oh, then I need to get the distance. xy is xs ln xs2 and ys ln ys2, and then ans for y if grid, so if there is a person, we add that distance. Let's call this meeting x, meeting y. This could work. Okay, nice. Interesting, that's a hard problem, but okay. Median O&M. In 1D, the solution is to pick the median. To adapt this into 2D, we pick median x coordinate and coordinate to make up which will be our meeting point, the total distance of neighbors from the meeting point. Iterate over the grid twice. Nah, it's NN log NM. Grid in O&M to find all friends coordinates. Then we sort them in O&M block nm, since there can be at most of them, and finally we go through the entire grid and calculate distance, the sum of distances of neighbors. O nm, I mean technically it's n plus m, median time, okay, n x coordinates, I mean that's not and at most y coordinates. Maybe it's like that, I don't know. Whatever, this is absolutely free, or free. I had to read the hint before, but because I already tried to do this problem, but turns out it was a variation of this. Anyways, goodbye.